This is part 2. Okay, so like I have said before, if a chain reaction is given and then it is not mentioned that there is fast equilibrium or there is slow equilibrium, then we will always have to use the steady state approximation. Okay, so in this question it's said that with respect to O3 at high temperature it is second order, and with respect to O2 at high temperature it is -1 order, and we have to prove it experimentally. First of all, what you have to do is always see which one is a reactant and which one is a product. Here O3 is a reactant, O2 is a product. So if I exclude this, that means O3 is excluded, O2 is excluded, then O2 is excluded, O3 is excluded, this one also, then we remain with O. Then we know that O is the intermediate, so we have to apply steady state approximation only to the intermediate. So I just equate it with 0, then I solve it. Well, the most important part is this one. Okay, you cannot make mistake in this part. You have to write the red equation of O using this mechanism process. Just see if O is being formed in the reaction or it's deformed in the reaction. Like in this case O is formed, so in that case you have to use positive sign. Like in order to write the red equation for this process, it will be K1 into O3 here. But in this case O is deformed. Okay, so it will be negative of K minus 1 of O and O2, like this one, negative of K minus 1 of O2 and O. In this case also O is deformed, so it will be K2 into O3 into O with a negative sign. This one, negative of K2 into O3 into O. And then you have to solve. First thing you have to remember is that apply steady state approximation, find the concentration of this intermediate. Okay, find the concentration of this intermediate. You don't have to find anything, just find O. And after that, apply this O concentration into another reaction. If there is only one intermediate, then solve the intermediate concentration and apply it to the red equation of the reactant, O3. First, you find the reactant red equation and then find the intermediate concentration using steady state approximation and apply this into this reaction. This in case when there is only one intermediate. Okay, and then after that you'll be able to solve it, find the equation, and this question, for this question, just see this part. Okay, this is important. So yeah, if there is only one intermediate, we use that thing. If let's say that there are two intermediates, okay, like say in this case there are two intermediates. Here is this is the reactant, these are the products. Okay, so this is a reactant, this is also a product, this is also a product, product and product. So these are the intermediates. NO3 is an intermediate, NO is an intermediate, so there are two intermediates. So first it's said to prove this one. Okay, so it's said to prove for oxygen, not for N2O5, so you don't have to write N2O5 formula, because first of all there are two intermediates and you don't have to worry about putting the value of the intermediate in the red equation of the reactant, so you don't have to write the rate of the reactant first. Okay, first the rate is given, I mean the equation we need to solve is given, so find for DO first, D of O2 first. Okay, and then you'll find this DO2 rate first, then keep it. After that, apply steady state approximation in any one of the intermediate, find the concentration of the intermediate. Okay, like say you're applying on NO3, then you find the concentration of NO3. Well, You're solving for NO3, find for NO, the other intermediate. If there was only one intermediate, you find the, here in this oxygen, you apply steady state approximation on the intermediate, find the concentration of itself, O itself, and apply that in the reactants red equation. But if there is two intermediate, use steady state approximation on any one of the intermediate, find the concentration of the other intermediate. Okay, and then apply steady state approximation on the other intermediate, and then use this equation, use this value NO. I put this one from equation number 2, and then I solve the equation to get the desired equation we wanted. Okay, and for this equation, for this one, which was asked in the exam, it's said to find to show that the reaction is 3/2 order of the formation of methane. Methane is this one. So forget about everything. We're asking about methane, but the reaction goes like this: CH3CO, it gives this C2H6. Okay, this is the product and this is the reactant. So there are numerous intermediates present here. Methane, although is not one of it, it's a byproduct actually, but then this is an intermediate, this is an intermediate, this is an intermediate, this is also an intermediate. But then for this question, just remember that we apply steady state approximation on CH3 and CH2CHO. Okay, so for this one is very different type, so just try to memorize it. Just try to, not by heart actually, but then try to remember that for this question it's little different. So you write the red equation of the desired reaction. Okay, like is in this case it's asked about methane, so write for methane. Previous question for that N2O5, it was asked for oxygen, so write for oxygen. So the red equation for methane, I've written it. After that, apply steady state approximation. Forget this step. Okay, forget this step. Apply steady state approximation on CH2CO first, and then find the concentration of CH2CO. I told you this one is different. Told you, no, that that this one is different. Now CH2CO. I'm using CH2CO here as a steady state approximation. I applied it, and then I'm trying to find the concentration of CH2CO. Okay, for normal application of steady state approximation in a chain reaction, we normally find the concentration of the other intermediate, but in this case there are numerous intermediate, so we just find the concentration of itself. Okay, after finding this, your next step is not this. After finding this, you write this one. Okay, again apply steady state approximation on CH3, solve it, and then you get something like this. Now after getting like this, put the value of CH2CO here, like I've done here. Okay, and you put it, solve it. At the end, you'll get the value of CH3. Then put this CH3 in the first equation which you have written, this one. Okay, now here you write it, solve it, you get the equation. Now the question is solved. Remember, I mean, I will understand, but if for you, I'm trying to make it easy. Okay, for that question, that methane one, write this equation and then apply steady state approximation on an intermediate. We get, do not write this one, write this one first, write till here, and then write this one, then after that write this, and try to remember this question. This one is different from others. Okay, and it's done. Only enzyme catalysis and enzyme inhibition is left. That one I've already made video. I'll upload it, and you see from there. And PDF also I'll send you of everything. Just study properly tomorrow.